Hello everyone, I'm Mariana Awad. I'm a researcher at the University of São Paulo, and today I'm here to present our work, Design Process for Pop-Up Architecture, Outdoor Comfort and Urban Revitalization. This project was developed under the collaboration of the researchers and supervisors, Cláudia Ferrara, Eduardo Gasparello, Laís Guzmão, Patrícia Coelho, Rodrigo Dias, Professor Alessandra Rodrigues, Professor Joana Carla Gonçalves, Professor Marcelo Romero, Professor Rani Loureiro, Professor Roberta Cronca. Well, this work will present a new type of design known as temporary architecture, ephemeral architecture, or pop-up architecture, which is based on a structure or interactive space that can be temporary, flexible, collaborative, and adaptable. This kind of design is contributing to work in the regeneration of underused urban spaces in providing more sustainable cities. The purpose of this project design is the requalification of open spaces in the city of São Paulo by offering the pedestrians possibilities of comfortable and inviting urban open places. The first slide, you can see some reference of this kind of temporary structure. Moving on to the local and urban context, the site for the project development is part of the Centro Universitário Maria Antônia Selma, which belongs to the University of São Paulo. It is located in the city center of São Paulo, Brazil, in an area of great concentration of cultural and educational institutions. Here in this slide, you can see our sites, the open space between the two buildings. Moving on to understand the climate context, the city of São Paulo is located in a subtropical region characterized by warm, humid summer days and drier winter days, with prevailing wind directions being south, southeast, and southeast during the year. The annual average temperature is 19.3 Celsius degree. Going on for the methodology, in order to settle the main conception of the project, it was taking into account the investigation of the microclimate conditions, user needs, and data collection. It was based on the measurements, recorded values of dry bubble air temperature, global temperature, air movement, relative humidity, sound pressure level, and the questionnaires about environmental conditions of the space, ergonomic, thermal, and acoustic conditions, and also with the use of Grasshopper design software, which is a combination of geometric design and simulation tools. And the simulation was also important to the development of the design process, because that it was possible to achieve the Selma's users' expectation using this kind of simulations. Going on to the empirical survey, the questionnaires pointed out user satisfactions regarding the general environmental perception, which is listed in the first slide. Also, the satisfaction level was higher from 9:45 a.m. to 10:15 a.m., as you can see in the other graph. Moving on to the design concept development, it was based on empirical analysis, as we already saw, and general understanding of the urban context and users' needs, which encompasses mobility, flexibility, replicability, dynamics, and the possibility of different uses for a public space designed for the permanence and passage of people. Also, in the design concept development, solar radiation's incidence analysis were important to define the type of roof material, where 4 hexagonals were made of translucent honeycomb polycarbonate and 3 of them were made of glued laminate timber. Also, this kind of analysis were important to help us to build the structure on the site. Also, the environmental concepts adopted for this design were important as a way to create a more flexible, shaded places, which allows different types of uses, such as exhibitions, social events, outdoor library, recreation, and permanence. Also, acoustic panels were proposed for the triangular structures to work as sound barriers. Moving on, the project was simulated to evaluate the solar radiation, natural lighting, and comfort levels using 2 software extensions of the Grasshopper parametric modeling. 2 scenarios was simulated, one without the pop-up structure, called reference model, and another with the insertion of the pop-up structure, called proposed model. It was possible to analyze the impact of translucent coverage and on the distribution of radiation and space lighting in the proposed model scenario. The simulation result in the proposed scenario shows a large decrease in incident radiation under the opaque coverage. Here in this slide you can see some images of this kind of simulations. Also, we would like to highlight the comfort index. The physiological equivalent temperatures PET were calculated for two cases. One with a seated person with the metabolism rate equals to 1.0 MET, and another case in which the user is walking through the coverage, an active that has a metabolism rate of 2.6 MET, as you can see in the graph. And finally, to conclude, a temporary structure was developed with conditions to be reassembled in other locations, with a lack of spaces for permanence and social living in São Paulo and in other places with different climate contexts. Also, the project developed in this work is a prototype, therefore it is still necessary that more tests with other modular changes are carried out in different places and climates. This research highlights the importance of developing an innovative design for temporary structure adapted to an urban context, considering the environmental comfort concepts together with technological design tools. And thank you very much.